missing value for tabular data x 45, 50, 55, 60, 65 and f of x values 3, blank, 2, blank, negative 2.4. Let us assume the f of x values as y0, y1, y2, y3 and y4. We have to find out y1 and y3. Since we are given 3 values of f of x, we will assume that f of x is a polynomial of degree 2, so that delta cube applied on f of x is equal to 0. Since we have to find 2 values y1 and y3, we will require 2 equations. First equation will be obtained from delta cube of f of 45 equals 0, and the second equation will be obtained from delta cube applied on f of 50 equals 0. We have assumed f of 45 equals 3 and f of 50 equals y1. Thus we have these equations rewritten as delta cube y0 equals 0 and delta cube y1 equals 0. We can replace delta by e minus 1. Thus we get the equations e minus 1 the whole cube applied on y0 equals 0 and e minus 1 the whole cube applied on y1 equals 0. Expanding e minus 1 the whole cube, we obtain 2 equations, e cube minus 3 times e square plus 3e minus 1 applied on y0 equals 0 and e cube minus 3 times e square plus 3e minus 1 applied on y1 equals 0. When e cube applies on y0, the output displayed is y3. When e square acts on y0, the output displayed is y2. When e acts on y0, output displayed is y1. Similarly, we have e cube acting on y1 will display y4 as the output. E square acting on y1 will display y3 as the output. E acting on y1 will display y2 as the output. Here, we are particularly focusing on inputs y0 and y1 from our assumptions, because instead of y1, if we had taken y3 here, when you apply e3 on y3, you will get y6, which is unknown to us. So these y0 and y1 are selected such that the given values itself can be depended to find out the missing values. Applying e minus 1 the whole cube on y0 and y1, we get 2 equations, and we have from the first equation y3 plus 3y1 equals 9 obtained, and from the second equation we obtained 3y3 plus y1 equals 3.6. Solving these 2 equations, we have y1 equals 2.925 and y3 equals 0.225.